In this section, I'm going to show you how to configure a network neighborhood. But firstly, what is a network neighborhood? Well, the network neighborhood defines the network topology of the traffic running on the test ports. So, for example, if you want to run IPv4 traffic or IPv6 or both, if you want to run over VLANs, behind virtual routers, GTP tunneling, IPsec, all of these various aspects of the test are defined in the network neighborhood. Now we can get to the network neighborhood through several routes. Firstly, let me show you the control center drop down. We can define a new network neighborhood. We can open an existing network neighborhood, and there are many predefined for you, or if you've previously gone in and saved a network neighborhood, that will be available for you there. You can import a network neighborhood from another test that you've got, or open a recent network neighborhood. If you were to use the test drop-down to create a new test, you will see that the network neighborhood configuration is at the top left, and the default network neighborhood is called BreakingPoint switching. If you wanted to have a look to see how that is configured, you can click on it and edit it, or you can use the button on the right hand side to browse for any other network neighborhood that's either predefined or you've pre-saved. I'm going to close this because I want to show you how to create a network neighborhood from scratch. So I'm going to use the Control Center New Neighborhood link, and this will open up a helper screen for me. So the first thing I need to do is decide what type of device I'm testing. There's a range of options for you. I'm going to select the IPS. That then gives me a visual representation of what the config is going to look like. And I'm going to go ahead and select that. Once I give it a name, I will then be able to edit it. So let me expand all of these drop downs. So we can see we have a test that's been configured with two interfaces, one IPv4 external host and two IPv4 static hosts. I don't need the external host, so I'm going to go ahead and delete those. So now I'm left with the IPv4 static hosts. So what are they? Well, the static hosts are a pool of IP addresses where we define the base address and the count, gateway and net mask, and each one has an ID and a tag. Because I'm going to be using this pool of IP addresses for the clients, I'm going to give the ID and tags a reasonable name of clients, and equally the other pool of IP addresses starting with 1.2.0.1 I'm going to be using as the servers. So I'm going to go ahead and give the ID and tag of servers. So I shall save that. And you can see that each pool of IP addresses is given a container, and in this case the container is the interface. So in this particular case we're going to have 65k of addresses on the client side going out of interface 1, 65k of addresses starting at 1.2.0.1 going out on interface 2. Now let's say I wanted to, instead of having those addresses going out directly on the interface, I wanted to sit them behind a virtual router. So I want to emulate a virtual router on each of those physical ports. To do that, I need to add a new element. So I use the Add New Element drop down, and I can see there's various configurations I can add. IP infrastructure, IP configuration, endpoint, and various mobility related configurations. So I'm going to go up here and add IPv4 router. That's now added one IPv4 router for me, However, I wanted a virtual router on each interface, so now I need to go to the right here and add a row. So now I have 2. I'm going to give them a meaningful name. And of course I have to define an IP address for each. And for each one I need to define a gateway. For my test to work, I need to define each virtual router as the gateway IP address for the other. I'm going to give it a net mask of 8. So I need to go back down now to the static hosts, and I don't need a gateway IP address for each of those now because they're sitting behind a virtual router. So I delete the net mask and gateway IP address for each. And now I can define for each one the container. So for the clients, I'm going to define the client router as the container, and for the servers, I'm going to define the server router as the virtual router. Now I go back up to the IPv4 router and define the interfaces as the container. And I'm going to save that. So now I have 65k addresses on each side, on each physical interface, sitting behind a virtual router. Let me take this one step further. Let me add a VLAN. So if I go here and add IP infrastructure VLAN, I want to add a VLAN for each physical port. So I need to again use the add row button. I'm going to add a reasonably named ID for each one. And I need to define a VLAN ID for each one. In my particular case, I need to define the same VLAN ID for both, otherwise my test won't work. So, having defined the VLAN ID and the container for each VLAN, I now define what I'm going to use to key on that VLAN on the physical interface. And I need to drop down now to the IPv4 router and define its container. So now the client-side router is going to be sitting on the client VLAN, and the server-side router is going to be sitting on the server VLAN. I'm going to go ahead and save that. So now I have 65k addresses acting as clients starting at 1.1.0.1, and I have 65k addresses starting at 1.2.0.1 acting as servers. They're both going to be sitting with containers that are virtual routers. Those virtual routers have a container that's a VLAN, and those VLANs have a container that's the physical interface.